All right, welcome back everybody. This is the second video in the sequence for Unit 1, Section 6 of AP Calculus, determining limits using algebraic manipulation. And we're going to focus, in the last video we did some simple straightforward substitution problems for algebraic manipulation and a couple of indeterminate forms. This video is going to, spoiler alert, focus exclusively on indeterminate forms and some different indeterminate forms, unlike the ones we've seen previously, and how we can handle those, kind of a little refresher of some algebraic techniques for us. So let's start with part A. We're finding the limit as x goes to -4 of the quantity x over x plus 2 minus 2, all of that over x plus 4. And if we do a quick little mental substitution with -4 in here, we get -4 over -4 plus 2, so -4 over -2, which is positive 2, minus 2. So the numerator is going to be 0, and of course it's pretty clear that the denominator is 0 as well. So this, in fact, leads to a 0 over 0, an indeterminate form. And so now I'm going to need to simplify this algebraically in order to find this limit. Well, the first thing that I'm thinking when I look at this as far as simplification is we really don't like to deal with fractions inside a fraction. So the first thing that I would do is take this limit and go ahead and get that fraction out of the fraction. So I'm going to go ahead and take the original, and I'm going to go ahead and multiply both numerator and denominator by the quantity that is in the denominator in the numerator. And when I do that, that means I'm going to take this limit and I'm going to multiply the x over x plus 2 times the quantity x plus 2, and I'm also going to multiply the 2 times the quantity x plus 2, since those are my two terms in my numerator. And in my denominator, I'm going to take that whole denominator, just multiply it by x plus 2. A little bit of advice in general. I should probably put that in parentheses. That's not my advice. But a little bit of advice in general with problems like this one, limits in general. I don't normally do much with the denominator of things until, the time goes by, unless it merits it. But a lot of times we'll end up with, some expression that we can simplify and one that's already in factored form. My denominator here is already in factored form, so that's going to be nice for me to just leave it like that. And I'm going to try and simplify what's in the numerator to get something that, leads to some type of cancellation. So I go ahead and I do my arithmetic here, and I've got to turn my Twitter notifications off. And I multiply these out, and that gives me just x when I take the x over x plus 2 times the quantity x plus 2. And I'm going to distribute the 2 through the other expression. And then I'm going to go ahead and simplify the numerator. And that gives me -x minus 4. And if it's not immediately obvious, that we're looking for a factor to cancel here, if I factor a -1 out in the numerator, we see that we indeed have a matching factor of x plus 4 in the numerator and in the denominator. And so then I can go ahead and cancel those out. And this becomes the limit as x goes to -4 of -1 over the quantity x plus 2. And then I'm going to go ahead and substitute -4 in there. That's -1 over -4 plus 2. And so we end up with a limit of 1/2. So that's one way that we can handle an indeterminate form. If we have a fraction inside of a fraction, we can go ahead and multiply both the numerator and denominator to clear the fraction, and then simplify algebraically from there, and hopefully good results will occur like they did in this example. All right, let's go ahead and move on to part B. The limit as x goes to 3 of the square root of x plus 13 minus 4 all over x minus 3. And again, I can quickly confirm that this is a 0 over 0 indeterminate form by substituting 3 in there. That gives me the square root of 3 plus 13, or 16. Square root of 16 is 4. 4 minus 4 is 0. And 3 minus 3 is 0, so we have that indeterminate form. So now I want to simplify this algebraically. And if we look at this, we think, okay, how can I simplify this limit algebraically? Well, it would be nice to get rid of that radical. And so what I'm going to do is I'm going to multiply the numerator by its conjugate in order to get rid of the radical. And so when I multiply the numerator by the conjugate, I'm going to also have to multiply the denominator by the same expression. So I'm going to multiply this by square root of x plus 13 plus 4 all over square root of x plus 13 plus 4. And when I do that, that gives me in the numerator, I've got x plus 13 plus 4 square root of x plus 13 minus 4 square root of x plus 13 minus 16 when I FOIL that out. And in the denominator, I've got the quantity x plus 3 times quantity x square root of x plus 13 plus 4. I simplify the numerator, and when I do that, the positive 4 root of x plus 13 and the negative 4 root of x plus 13 cancel each other out, and then I can combine the numbers, and we end up with just, what is that, x minus 3 in the numerator. Oh, somehow I changed my little transcription error. Hope some of you caught that and were screaming at your screen. Changed my x plus 3 to an x minus 3. So and now those x minus 3's can cancel each other out, and I end up with the limit as x approaches 3 of 1 over square root of x plus 13 plus 4. And now we substitute to find our limit. And we end up with a limit of 1 over 8. All right, so that's the second situation when we have a radical, and we need to use the conjugate in order to clear the radical. And one more example here, if I can move my screen down, there we go. Our third example, part C, we take the limit as h approaches 0 of this expression. If we substitute 0 in here for h, we end up with square root of 5x minus square root of 5x, which is 0 over 0. So again, this is a 0 over 0 indeterminate form. Again, notice that when I was doing these, never at any point did I write equals 0 over 0, because they are going to dock you for that on your AP exam nowadays. They used to be a lot less stringent about that, but in recent years they've become much more of sticklers for that notational clarity. All right, so in this one, again, I have radicals. So again, I'm going to use the conjugate in order to simplify this. And so I'm going to multiply the numerator by square root of 5x plus h plus square root of 5x. And same thing for the denominator. And then I'm going to go ahead and simplify this. It leaves me with h times the quantity square root of 5x plus h plus the square root of 5x in my denominator. And in my numerator, leaves me with, the two middle terms are going to cancel out since we're multiplying by the conjugate, so I'm not going to bother writing them. It leaves us with 5x plus h minus 5x. Now the 5x's cancel each other out. And I can cancel an h from numerator and denominator, and this becomes the limit as h goes to 0 of 1 over square root of 5x plus h plus square root of 5x. We take the limit now by substituting, since we have a clear numerator. And we end up with 1 over 2 square root of 5x as our limit. All right, that's it for this video, video number 2. For those of you who are in my class, if you go to the next page, you'll see some practice problems on finding limits algebraically, and also notification that you have an assignment on my AP that's due before the start of next class. For those of you who are joining me otherwise, thanks for joining us. You can come back and see the next section, section 1.7, as soon as we get on to that video. All right, have a good rest of your day, and I'll see you again in the future.